Hey guys. Alright, so I'm going to work an example problem from 4.2 graphing polynomial functions, and I selected a problem out of your homework, and what I'm going to do is show you. I do all the steps, but it's just how I work through it. Now this isn't the exact way that I do it. You could say I cheat and use my TI 83 or 84, but I still work the problem out and don't just go with the graph. I do it so that I can learn. So let's look at the problem. Let's see, I have was it x to the fourth minus 4x cubed plus 3x squared equals 0. And then I know from my lead term test, I have a 1 and a 4. So positive coefficient, even exponent. I know it looks something like this, and what's going on in the middle, I do not know. Next, I factor. I'm going to find the zeros and look at my multiplicity. 4x plus 3. Okay, here I can do my multiplicity. Okay, so I know that I have a multiplicity of 2 here because I'm going to write this over to the side, my multiplicity. I know that this is actually x squared minus 0, or sorry, x minus 0. That's how I can write that so it follows our form. And that's a multiplicity of 2. It's even, so therefore this one is tangent. Okay, this one here, it crosses, and this one here crosses. All these concern x-axis. Remember, tangent to the x-axis crosses and crosses the x-axis. So I know how it looks from my multiplicity. Now I set everything equal to 0. X squared equals 0. X minus 3 equals 0, and x minus 1 equals 0, such that I know my x values are 0, 3, and 1. So my points that I'm looking at, 0, 0, there's my y-intercept, 3, 0, and 1, 0. These are all my x-intercepts. What I'm going to do is draw me a number line here, and I'm going to put in 0, 1, and 3. And what I'm looking at are the intervals separating those. I'll put a red dot. Hopefully that shows up. So there's a red dot. Those are my zeros. Okay, and I know that here going this way is a negative infinity, and this is infinity. So what I'll do, write my intervals right down here. So I got a negative infinity to 0, 0 to 1, 1 to 3, 3 to infinity. And then I'm going to pick a number out of each one of those. So let's see here, and I pick an easy number. I'll say x equals negative 1. I got to have a fraction because it's less than 1. So, oh well. And then here, x equals 4. Again, my end behaviors, I could end up with a large y value once I plug it in. That's just how the ends work. And next, I'm going to plug those values in. I'm going to solve for the function. So f of a negative 1. And you know what I'm going to use? This will probably be easier to do the math instead of taking stuff to the fourth power and the third power. I'm just going to use my factored form. These two are equivalent, same thing. So negative 1 squared, negative 1 minus 3, and then negative 1 minus 1. 1, negative 4, negative 2. So f of a negative 1 equals 8, and it's positive. And then f of 1/2, so that's 1/2 squared, dang it, times 1/2 minus 3 times 1/2 minus 1. 1/4. I'm going to rewrite 3 as 6 over 2, and I'll rewrite 1 as 2 over 2. so I can add and subtract my fractions. That becomes a negative 5 halves and a negative 1 half. The negative is a positive, so 5/16 is my answer for that one. So f of 1 half is equivalent to 5/16. F of 2, that's 2 squared, and 2 minus 3, and 2 minus 1. Okay, I can already see I'm going to end up getting a negative answer for this one. So 4 and a negative 1 and a 1. So f of 2 equals a negative 4. Let's see if I can slide this over some, squeeze this one in. So f of 4, that's going to be 4 squared, and then 4 minus 3, and then 4 minus 1. So I end up with 16 times 1 times 3. So f of 4 is equal to 48. Sorry, positive, positive, negative. So I can go over here and I can look at those values in that interval. We know from in behavior that this is positive and this is positive, and my values indicate that. At a negative 1, I got the value of 8, it's positive. At 1 half, f of 1 half, the answer was positive, and that goes along with my multiplicity because I know it goes tangent to 0. At 2, this validates my 3 and 1 that it should be negative, and it is a negative 4. And then at 4 is positive, which validates my end behavior. So I know my graph does something like this. So make sure y'all can see everything. I know my graph does something like this. It comes down, it's decreasing, it intersects that 0, and then it's going to go back up for a little bit. And it's going to go along, and then it's going to intersect and cross the x-axis and go down and come back up and intersect and cross the x-axis at 3 and go back up. And see in behaviors, and what I've just kind of got a rough sketch of is what's going on in the middle. Okay, I already know my y-axis. Whenever x is 0, y is 0. And I've done everything, and this is kind of my rough sketch. So let me pull up my calculator. I'm going to pause the video and type all this stuff in. Okay, I've entered in, here I'll go back to that. Okay, I've entered in the equation x to the 4th minus 4x cubed plus 3x squared. Okay, and I can go to my table also and set up, so let's say I want to start at 0, and my value is 0.5, so I could change that 0.5. I'm picking my lowest form of my x value, so I'll go through there and it'll give me increments of 0.5, and then I can go to my table and I can scroll down and find all these values and verify. So at a negative 1, my value is 8, and that's what I got. And at 1 half, my value was 0.325, and that would be 5/16. And then let's see, what was my next one? 2, negative 4, yes. And then at 4, 48. Okay, so I can use that, and then I can also look at my graph. And if we look at the rough sketch that I made, along with what my graphing calculator is actually giving me, that's pretty good. What I do not know is really a maximum here value, and I don't know a minimum value here. I don't know what they actually go to. So I could plug in additional points. I could say something like I did 2, so I could do 1.5 and 2.5. Plug those in also and get a value until I finally got it to where I knew how far down it went. Same with here. I could plug in different values, 1/4, 3/4, to where I kind of had an idea of where that actually is. Alright guys, this is how I work through the problems. And to be honest with you, I work everything out. I don't go just to a graph and calculate whenever I do this, even whenever I do my calculus homework. I still work it out by hand, so I have that conceptualization, that understanding. I use this as a tool. This right here, all of this can be busy work, and that's what can take away from that's what can add a lot of time to working your problems. What I will use is I will use my table to be able to answer a lot of those questions and be able to answer them quickly. Okay guys, continue to watch the publisher's videos, structure and critically think about your homework, and good luck on your homework.